Hi! In this tutorial, we'll explore the integration options for the UniControl IoT devices you've created. Starting with the factory fresh UniControl firmware, I'll guide you through utilizing the latest interface features to ensure a smooth and simple integration. While you can configure your device however you prefer, it'll be easier if we both import the same settings from the supporting article linked below. Download both the device and process files from the website to your computer. Use the import function in the system menu of the interface to upload them to the device. The device and process settings need to be uploaded separately, but they serve as a good way to back up or share the entire configuration. Once uploaded, you will see the changes immediately. Your device now has two processes, one for controlling the onboard LED on the D4 pin, and one for measuring the temperature with the DHT22 sensor connected to the D5 pin. This is visible directly in the process parameters as well as in the peripheral menu, where D4 is set as a general output, and D5 is defined as a digital input specifically for the DHT22. The MQTT parameters are also pre-filled, making the device immediately accessible via MQTT. In the system menu, you can see that the device has already established an active connection with the broker. The device is ready, so we can proceed with integrating it with Node-RED, starting with the temperature feed. In Node-RED, drag and drop an MQTT in Node. Before it can accept any messages, it needs a broker definition. You can easily use Mosquito's free test broker by entering its domain. To obtain the topic with temperature readings, navigate back to the interface. This topic is readily available in the Input Publish tooltip. Click the clipboard icon next to the topic and head back to Node-RED. Paste the copied topic and confirm. You can verify the data flow by adding a debug node. After deploying your flow, the data will start coming in immediately, so it's time to create a thermometer gauge. Drag and drop a gauge node into the workspace. With a few clicks, you need to create the missing dashboard tab and group. This will establish the location of the gauge within the newly created dashboard. Give the gauge a name and set the expected reading range. Your first draft of the dashboard is now complete. Deploy the flow again and navigate to the brand new dashboard. The gauge will update as soon as the next temperature feed arrives. Let's try the same thing again, but this time using an HTTP request. The HTTP request needs to be initiated by the flow, so drag and drop an inject node to handle this. Next, add an HTTP request node, which will perform the data exchange. To save yourself some setup work, you can also copy and rename the existing gauge node. You will find the exact URL address, returning the temperature reading in the same tooltip from which you copied the MQTT topic. Go back to the interface and click the corresponding copy icon. Paste it into the URL field of the HTTP request node without any adjustments. In the inject node, set the interval to a reasonable level. While 10 seconds may be unnecessarily short for a live application, it ensures we don't have to wait long during testing. Deploy and check the results. With the temperature being retrieved via both MQTT and HTTP simultaneously, we can now move to controlling the LED process. Add a new switch node to handle user interaction on the dashboard and send impulses when switched. Next, add an MQTT out node to relay those messages to your device. UniControl requires this message to contain either 1 to switch the process on or 0 to switch it off, so you will need to adjust these values in the switch node. Name the node and proceed to the interface to obtain the topic on which the device will listen for the corresponding commands. You will find it within the LED process, in the tooltip next to the on and off buttons in the output section. Paste it into the appropriate box in the MQTT Out node, finalizing the MQTT LED switch. To repeat the process for the HTTP case, drag and drop another switch node into the workspace. These nodes can coexist without interfering with each other. To establish communication for this stream, add another HTTP request node to your flow. You will find the URL for it in the same tooltip as before. However, we need to modify it slightly to handle both on and off cases with a single node without making the flow cumbersome. Cut away the last parameter in the address, as we will append it back with the well-defined JSON objects. They will be defined as on and off payloads directly in the switch node. Be sure to select the correct payload type and follow JSON syntax. Deploy when done, and you're ready to check the final dashboard. You may want to reconcile the dashboard actions with the interface, as it gives you a real-time view of what is happening on your ESP8266. You will see that switching either button changes the state on the D4 pin, completing our Node-RED integration. Let's do it all over again in Home Assistant. Begin by ensuring it is connected to the same broker as your device. This is straightforward, as Home Assistant only supports a single broker. The core of the work in Home Assistant will be in its configuration file. Navigate to the file editor and open the configuration.yaml file. Configuration can be challenging when starting from a blank page, so having a starting point is helpful. In the supporting article, you will find preliminary YAML definitions that we can use. This code contains general definitions and hierarchy for what we need. We just have to replace the placeholder strings with real topics and addresses. Paste the entire configuration into Home Assistant and start filling in the placeholders one by one with the same strings we used for Node-RED. The only exception is the LED state feedback needed by Home Assistant to update the switch states, ensuring they always send the correct command, which was omitted in the Node-RED example. You can find the necessary information in the Publish row of the LED process output section. Be careful to select the process variant that follows the intuitive logic where 1 stands for the LED being on and 0 for off. In this specific case, it is inverted from the real behavior of the ESP8266 onboard LED, which glows when the D4 pin is low and turns off when it is high. Remember that all the provided code is built using standard Home Assistant YAML syntax. When you are done with this little exercise, save the file, check if the configuration meets the basic stability criteria, and restart Home Assistant. Once everything is loaded, all the building blocks will be ready, but we need to create the dashboard first. In the Dashboard Settings menu, create a new dashboard from scratch. Give it a name you like, and you may also set it as the default to hide the original one. Navigate to the newly created dashboard, click on the Edit button, and start adding the cards. Often, you will find your entities waiting for you right away, though sometimes you may need to search for them a bit. Your new Home Assistant dashboard is now complete, and you can test how it works against the UniControl interface. This rounds up our small integration example with both Node-RED and Home Assistant. However, the real possibilities are limitless and waiting for you to explore. That's all for today. I hope you learned something, and I'll see you in the next video.